To start with, yesterday we started with the introduction to collections objects and Java collections. Primarily, we are focusing on list. We are focusing on list, then set, and then. So we looked at how do we really create list object and a set object and a map object. Primarily list, the hierarchy is that they list and set extend from, let me open, let me just open this particular thing so that it will be clear. In Java, we have, just look at, I'm not sure whether is this readable for you?
No.
No? Oh, okay. And let me just, yeah, it might be better now, right?
Yeah.
Yeah. Yeah, this is the class hierarchy. Remember any topic that we look at in Java or maybe in any other object-oriented language, we need to know the complete hierarchy, and that will help us. Okay, so look at this. There are two diagrams. So primarily list and set are called collections. The basic stuff is the base is collection. There is an interface called collection that has some methods, and set and list are again interfaces. Okay, so they are extending the collection. Collection. Interface can extend other interface, right? I'm making a statement. Interface can extend other interface. Is this correct statement? Class and interface logic. Class extends another class. That is correct, right? Yeah. And class implements another class. That is correct. And how about between interfaces? Interface implements interface or extends the interface?
Implements.
No. Interface never implements anything. Interface is a definition only. So, class implements interface is correct. Okay. We looked at multi-level hierarchy as well, in the sense a class can extend another class, or class can implement another interface, and the next one more class can extend this particular class. There can be the way you have hierarchy here, one interface, then you have class. You can have multi-level hierarchy, but that's only like between classes, and extends keyword. Simple blind rule is that a class can extend another class. Okay, a class can implement another interface. Okay, and but when it comes to interfaces, only when you're talking about plain interfaces, an interface can extend another interface. Because extending another interface, actually in terms of interface language, means that, say suppose my first interface, say suppose collections here. If this collections interface has, say, two methods. Now, I think that in case of set, I want to add one more method to the interface. Okay, but still I'm not talking about implementation. I'm just talking about defining the methods, or declaring the methods in the interface. So what I do is I create one more interface which extends the actual interface, and in my interface I write one more method. Now there will be three methods that are declared but not defined. So between interface to interface, you always use the keyword extends. Okay, so there's about I have not tried this sample, but I did discuss about this keyword.
Excuse me, Haruna.
Yeah, yeah, please.
Can you briefly explain this again?
Yeah, I'll do that. Or maybe I'll take, I'll go back to Eclipse. Yeah, this is where, I always see and relate whatever we are doing. It's always, at least, it is very much related with other topics. You cannot just learn, just collections plain, what I will do is, this is about interface, so I'll just create it, then demo, and I'll even give the package name is okay. So because so now I will define one interface. Now I will not have any logic, business logic, so I'll just create a plain one so that I save some time thinking about logic and all. Public void, okay. Say hello. You all agree that this is a valid code, right? Plain interface.
Mm-hmm.
Okay. So now I'll say another interface. Here I cannot do implements. I mean, interface cannot implement anything, right? It is not a class, so it cannot implement. So what I'm saying is interface extends. Now in my interface demo was not supposed to be. Okay, I'll make this as a class. Okay, and maybe just say I'll choose. Yeah, I'm choosing the second interface. See here, my class now, first class implements second interface. Okay, how many methods do I have within the second interface? Only one here, say by. But then that extends first interface. So that is the reason my particular class that implement this interface has to write two methods. Say hello and say bye. The reason is that the inheritance
Oh yeah.
concept works between interfaces. You can extend another interface. One interface can extend another interface. Why there is always a little bit of confusion. I mean, we learn about extends between only you can extend only one interface. Sorry, one class can extend only another class, and not multiple classes. But we can use implements keyword and implement multiple interfaces. Okay, now we primarily focus more onto classes and interfaces, the relationship between them. Now, if you only consider interfaces, then what happens is an interface can extend another interface, as we have seen here. Is this clear?
Mm-hmm.
Yeah. So that's about interfaces. I'll not run the main method such as now. I'll go back to, yeah. So actually my browser. So the hierarchy here is what I was trying to explain was Java has collection and interface that is extended by there is interface called set and there is another interface called list. Okay, and now you have hash set. You have hash set. That is a class that we used yesterday, and now on the left side you look at hash set, and on the right side for the list we have something called array list. Okay, this is what we actually try to do samples for list and uh, set. Now in the bottom you look at, there is a map interface. See, there is a map interface. I know there are multiple implementations. Hash map, there is a tree map, there is a hash table, sorted map, and linked hash map. Now, I'll actually focus only on three particular classes here, and we will look at them in detail. I'll other things I'll leave that as an assignment for you, or if you are interested or you have really some doubt, uh, I'll not really create samples for it. But I'll just give you an overview of, I'll speak about those classes. Now I'll focus only on hash set, array list, and hash map. Now, we will look at, how or, how the methods are there, or I'll take you to those interfaces. From here, I installed map, right? I installed the decompiler so I can press F3. I think I did send a mail to you people that how to. Oh, this is wrong. Public abstract interface map. Uh-huh. Okay. No. Decompiler is doing some magic. What I'll try to do is use collection. See here, actually you see that there is one interface collection that actually extends another interface called iterable. Okay, I'll talk about that as well. So this has methods like size is empty, contains, just declaring the methods. To array there is iterator. Then to array has two different methods. One is a generic set of objects, another one is you can specify a particular type. Add, remove, contains all, add all, remove all, retain all, equals hash code. Okay. Now, what is that extra that I am getting from? What is that extra that I am getting from set? Yep. See here, correct. Here you see that set interface extends collection interface. Okay, and unfortunately, this actually gives all the methods that are available in the. Do I have any extra method? Okay, there is a problem with the decompilation. It shows more methods for collections interface, sorry, collection interface, but set method should have set interface should have at least a few extra things. Do I have anything extra here? Okay, I'll not try to diagnose what methods are there in the each of them. Rather, I'll focus on what these methods are. See here, I mean, the same diagram that I explained you, that there is a collections interface followed by set. There is another interface, set extends collection. So then list is there, list extends collection. Okay, there set and list are interfaces, and hash set, hash map, sorry, array list are the implementation that I wanted to talk about. Now there are couple of concepts here. One thing is maybe I'll try to explain each method what that really mean. I explained, size means it gives you size. Is empty means it is whether that particular collection object, the array list or hash set is empty or not, whether there are any elements or not. Next, contains. Contains is about searching. You give an object and see whether this list or set object contains this particular uh, given given object or not. Okay. Next is iterator. I'll talk about this particular thing that needs I mean good attention to detail. So how that really works is, let me come this particular part. So how we do that is, now this list is sorted. Now you see that collections.sort is sorting the particular list that we saw that yesterday, but then I'll actually extend this code. This is a list only, and why do I have map object here? I was see here I have this iterator method. Okay, when I call that, I actually get one iterator object that is actually yeah. But what I get is an object that helps me to walk through all the objects directly. This is one way you can browse through the objects. Next, what I can do is, for each not this, I mean, for list you don't see too much of complexity, but in case of map and in case of map you see that real benefit. while iterator dot has next. See here how I am accessing it. While iterator dot has next, what I'll say is string is equal to dot next. Primarily, it helps us, iterators help us, they have actually, I think, how many methods? Three methods. Let me iterator dot has next, and remove method as well. Let me go back to my browser. Yeah, remove method. They primarily have three methods. So they are actually, they help us to, it's actually like, to browse through all the objects that are there in a collection object. Okay, it could be list or it could be set. So this is how I access it. I'll create iterator IR or ITR, or in my case I mentioned an iterator, but I being a small letter, my object name equal to demo list dot iterator. And then how I can access this iterator dot has next. Okay, that means it always gives you whether you have next element or not, so that you don't run out of end of file kind of exceptions. Now string a string, you can give a proper name here. I just gave a small string iterator dot next. Now you can print the value. Now this is what iterator is. You just, it will give you a snapshot of objects available in the particular collection. It doesn't contain any other methods. See here, it doesn't contain any other methods. It is only to access the data that you have in the collection. But actually for list case, in case of a list, I can always say, see here, this is a different type of for, okay. This is called enhanced for. See, I'll again, pay little attention. This is not really related to the collections, but because I'm talking about it, what we can do is that, when I'm accessing, see, the list name is called demo list, right? What type of object I have? I am storing, see here, string. So what I can do is I can use a different type of for. Generally for loop contains what? For contains initialization logic, right?
Initialization.
Initialization followed by
Yes.
termination followed by increment condition, right? So that is a typical for loop. But what I can do is I can use this kind of for loop where, in Eclipse, the advantage with Eclipse, is that suppose if you are talking about, if there is a collection object before, if you are using some collection object, and after that you press, I'll delete this, you press for each, when I press for each, see here, and immediately it creates a different type of for loop. Meaning, to iterate through a collection, to iterate through a collection object, And to do something with every object, what you can do is, one option is that you can use regular for loop. Okay, but other option is you can just use this enhanced for, where it says you can actually give a name to this. Okay, so again, that is a generated one. So now what I can see is, oops. So this also prints out all the values. Please see this, please try this out. There is nothing much of theory here. It is more like, in one way to make the life easy for the developer, or maybe that, lazy for, I mean, in one way it makes us lazy, but other way is that we don't really need to care too much about the basic stuff, so that it will be taken care by the system, and we never do mistake in that case, and we put our brain and effort into implementing complex logic. So that is the benefit of enhanced for loop. Now here in case of iterator, did you get what I'm trying to do here? Iterator.
Yes.
Yeah, so I just browsing through the objects. Okay, you have a snapshot of it. That's called, that's about iterator. Then what you have is, maybe I'll just open the list object itself and look at it. We don't need to really worry too much about the hierarchy, but you should always know that. Um, yeah. So that's about iterator. Then there's something called to array. We'll look at to array. What happens is, okay. So demo list is a list, right? No, to array. I'll just say, see here, what I did was, I'm because to array gives you the basic type of objects, means the way you get that, reference will be an object array. Not the, I know that, this each object is a string. I know that each object here is a string. But if when you store some, but then, the way it returns is that this is a default method that you have, with the old version of collections also we had this method. So this is there as it is. But there is another method that I prefer. What happened to me? I used it so many times, but this is a bit tricky. To array, I usually give new string of 0. Yeah, this is how we need to give. Sorry. Now see, in this case, what I'm doing is, the second statement. Just pay attention to the second statement. I'm I'm actually creating an array. I'm getting an array out of the list object, array list object that I have. Okay, this two array means just converting the given list to an array. Okay, so the syntax is that you need to give an array. I mean here I'll just remove this and I'll press Control space. See here, it says T array, param array of T. Okay, I need to. I mean you need to specify a syntax like this. Okay, so then it will convert you to returned list will be of string. Sorry, returned whatever array you get out of this particular method call will be a string array. If you don't specify anything, you get an object array. See, in terms of what really the values are there here and here, the either string object array or string array here, demo list values, or let me name this as demo string array. Okay. Now let's we will. I'll actually have some debug point. What is the problem? Mm-hmm. So there are so many things in Java, at high level, if you see, looks like there's so many classes and all that. But fundamentally, to use them, that pretty much should help us. Now, see here, iterator example. What I'm doing is, let me F6, iterator demo. So now, what is that? Iterator values. You see that it actually has. It doesn't print out much here, but let us see here. This, I mean, it actually holds some reference for the particular list object. I mean, whatever values we have, and next F6, it prints out the values. So I'll go on. I did sort here and then print the. I did sort and print the values. So now let me look at this. Okay, object array. What do I have? Object array has first, fourth, second, third. Okay, this is a sorted list. Why it was sorted? The list is sorted not in the order that we added, but a sorted list because of this collections dot sort. You give a collection object, it will sort out that object itself. So just the demo list object itself will be sorted out. It will not return anything. It will just sort the given object itself. There is an object by reference usage there. Now, yeah, okay. Now let us look at this. Here, either you use demo string array or object array, they contain the same set of values, but the way you refer to them, there's of object type, and you cannot use that as a plain string. You need to do a typecast and cast the class to string and then use it. In case of string, if it is just a string, it doesn't really hurt. I mean, it looks like almost same. But if you are using a specific type that you declared, you declared a class called student, and you try to use, you have some methods like add student or display student or get registration number or something like that. When you have methods, then you can the second method, here demo list dot to array, and here what you will be giving is new student of 0. that gives you a student array. In that case, you get directly, you get a lot of benefit, because you get a student array directly. But otherwise, if you only look at object, if you treat that as an object thing, object array, demo list dot to array, what happens is that object methods, object has very primitive methods. Object has very primitive methods, in the sense it will not contain the additional logic that you will be having, but you can pretty much see what the methods object is having. It has get class hash code equals clone. Oh my goodness, it has, they are adding so many methods. Not very often people really look at how many methods are there, what they really mean and all, but predominantly uh, we need to be interested with at least three methods. This three methods: get class, hash code, equals. Again, object comparison related logic, I will explain that tomorrow in the next class. Okay, so I'll close this, but you will not have custom methods there. So this is how actually the two array method works. How the two array method works, two of them. Add method we already looked at. Add method we already looked at. That is add an object into the list. Now let me complete or stop that demo. Okay. Now other method that we have is add remove. Remove actually removes an object from the list. Remove. See here, I need to give the index. Maybe I want to remove third object. So it will remove that third object. Whatever comes in the list, that particular third object, index 3, will be removed. Okay. So that's self-explanatory. Next, other method that we have is contains all. Contains all is about, suppose I'll do a sample here. So what I will do is list of, I'll create just another thing. Okay. I will call this as a sublist. Put a new array and a list of string. Then sublist dot add now I can call sublist dot see here, contains all. Contains all, I'll give them as sublist. And what does it return? It returns a boolean flag. Okay, so that's about contains all. Contains is about a simple contains, meaning demo list dot contains. Here you can specify something like specific value, whether your first object is there or not. Okay, okay. In case, okay, I think I used. Okay, everything in small letters in case of. Yes. So contains and contains all, I hope you understood it. Did you really get what that contains all is all about? Yeah, can someone respond to me? I mean, it might get too boring when I am only the one man doing it. So please see if you have any questions, you stop me. Did you get contents and contents all method logic, what it is doing?
Yeah, just the boolean value, true and false.
Sorry,
The
can you come again?
it gives the boolean value, true or false.
Yes, a boolean
If it
value. Yes,
contains
yes, yes. Correct, correct. It says whether it is there or not. If it is true means, okay, that a particular given object is there. In case of contents, here it will written whether this particular given object is there in the list or not. Okay. In case of this one contents all, what I'm doing is I'm actually giving a sub list. I'm giving a list and saying whether check whether this particular list object, my demo list is the bigger list, whether this contains all the objects that are available in the sub list. Sub list is a small other list that I created here. Only 2 elements. Clear? Right. I'll try to talk about other methods. Now I'll add all is about adding all elements from another collection. So similar to contains all, add all is also takes one other collection object, another list object. Okay, and add all, there is another method add for add all where you can give integer that actually is the index. I'll not do the decompiled. I'll not look at decompiled class. Demo list dot add all. I think this is about where to start. In the list, generally by default, it will add to at the end of the list. Now this will add from the given location or into parameter. I think so. It will add all of them. From the given location in the list. Okay. So you just try it out. I'll not spend too much time on that. Remove all. Remove all removes all the methods, if you give a collection and if I say remove all means whatever objects are there, let me look at, here, contains all, right? Instead of that, if I say remove all, means what it will do is whatever objects are there in the sub list, if they are present in the demo list, it will remove them, all of them. Whatever objects are there in the sub list will be removed from demo list. Okay. Retain all. Why is okay? I have never used retain all. Only when but this seems to be doing retain. I don't see any Java docs as well. Okay, I'll just look at that particular method, what it is, and get back to you on that instead of spending too much time. Clear means it removes all the objects that are there in the this thing, list. Equals and hash code, I am getting it from the base object class. They are overridden. This particular array list will be overriding that and providing its own implementation. Then get. Then there is something called set. Okay, add, remove, index of, last index of. Okay, you have a get method here, and it's easy for me to talk about demo list dot. Let's see, to array size. There is something called sub list. See, sub list is about see that it is parameters. Maybe I think it is a starting parameter to ending parameter. So from this parameter, first value to second value, whatever values are there, it will create a sub list out of it and return list. Okay, and remove all, notify all. Okay, get is about retrieving a particular object. If I say get and give, say suppose if I want that fourth location, demo list. Yeah, it's in the it takes a parameter of number and it will give you the get. So get returns in this case string. It will return whatever we stored there. It will return the fourth object. That is fourth index means 0 to okay fifth element. Okay, so I think I'll skip other methods. I'll leave that as an assignment for you. Please do that whatever we are discussing. So please try sample for every method. Okay, like that whatever I'm doing, you try to do it, and you have any sure you will have questions. You come back to me. Okay, that's about the list, and then what let's look at the set as well. So the benefit with when I'm working with set is that it will not store duplicates. We looked at it yesterday. It will not store duplicates, and we pretty much looked at we are by giving different values here. We pretty much just to follow. So it will only add unique values into the set. Set logic is always about that, and it does not give any guarantee about order that we entered into it. It does not give any guarantee. This is Jimmy, your observation was pretty much correct. That set and map, they will never give the values in the same order that you entered. In case of a list, yes, they guarantee. There is a guarantee that in case of a list, whatever way I add the objects there, when I get the values back, and provided I am not doing this collection.sort, before that if I do this, then it will print the objects in the same order that I entered. But if you try the same thing with set, it will not guarantee that. It will be the order will be in its own format. That we cannot guarantee how it should be doing it. Now there is a sorted set as well. The sorted set object has set is fine, but sorted set. Let me look at the diagram. There is a sorted set interface. Okay, so that has an implementation called tree set. If we are using tree set, then there is a that I think is a binary tree. So the objects will be in a sorted fashion. And now Eclipse. Okay, so in case of set also you have demo set. I'll not talk too much about already we looked at iterator, so it will also has this method remove object. In case of set, see removing an object. In case of a list, we were giving in case of a list also it is same. The given object is removed from the collection. That is if you are working with the list, it is list, otherwise it is if it is a set. Remove all, return all, size, to array, to string, wait. Okay, they are the same set of methods that we have in list. Okay, so I'll not give any special talk about that. So I'll leave it to you to explore. But as long as you understand the difference, that a list is an index based one and it can store whatever you enter. If I enter same object 10 times, yes, the list will contain 10 objects of same value, okay, or same objects into 0 to 9, starting with 0 to 9th position, they contain the particular values. But if I enter same value to a set 10 times, it will not really hold 10 values there, it will rather hold only one value. It always compares whether when you are adding an object, it will check whether I have this object in my list or not. Okay. So one moment. So what actually happens is that it will store only unique set of values. Now there is a map demo. In case of a map, okay, what I will do is I'll leave this for. Okay, I think I should discuss this as well, but I really don't have time now.